Swayam Prabha. Digital India. Educated India.
And welcome back to the Basics of Working Drawing series. So today we will be looking at the second part of the discussion that we had last time, which was on plan preparation. So we are looking at plan preparation part 2, wherein we will be discussing upper terrace floor plans, upper floor plans and roof plans. So 3 plans. In the previous module we discussed the foundation plan and the floor plans, right? So moving forward, we are going to discuss the floor plans, typically the upper floor plans in this particular module, right? So what are upper floor plans? Upper floor plans, as the basic idea is dependent on the lower floors, particularly for structural support and the orientation, meaning what will be the access way to the upper floor, whether people will be coming to the upper floor through a lift, or they will be using a staircase, or they will be using a ladder, or the other options which can be put in place, right? So the variety of reasons upper floor plan are dependent on the lower floors. Also for electrical supply, the supply of services, utilities, the drainages that are to be brought from upper floors to the lower floors, for all of those things. Okay, so moving forward, the idea is drafting the mezzanine floor plans and floor plans with cantilever design, different types of roof, and the main information that needs to be shown in them are discussed in this particular module, right? So what all things we will discuss? We will look at the drafting of mezzanine floors, we will look at how floor plans connect with the cantilever designs that we can have, the different types of roofing that will be a particular building would require on top of it, and the main information that needs to be understood along with all of these different modules, right? So that is what we will be looking at, right? So what all other things are there? The basic drafted layout that is to be discussed, the hatches, the symbols which are used in the upper level floor plans are all that, all of those are pretty much same when we look at the ground floor plan and the upper floor plan, meaning that whatever process we discussed about drafting of floor plans in the previous 2 modules, the same things are also valid in case of a upper floor plan, right? A very simple thing to remember, right? Then when we look at the alignment, right, particularly the column alignment, the staircase alignment, the roof plan alignment, all of the representation which is to be done for a particular upper floor plan or a roof plan or a terrace plan is discussed in this module. So what are the ways to do representation of upper floors in the lower ground floor or lower floor is discussed here. Apart from that, the lower ground floors, how do they reflect their own conditions and their own entities in the upper floor plans, those things are also discussed, right? So moving on forward, let's try to look at the basics of upper floor plan, right? So in the upper floor plan, 2 things become extremely important. One is the column layout and second is the grid alignment. So the very first and foremost thing which is extremely important is when we are drafting an upper floor plan, or for that matter try to imagine an upper floor of a building. Try to imagine if a column is misplaced, right? A column does not reach completely to the upper level. What would happen in that particular place? Probably the upper floor plan or the upper floor will come crashing onto the ground floor or the lower floor, right? So for that particular reason, we need to be extremely careful when we are doing the representation in the drawing, right? So here what do we say? We are saying that the first and foremost aspect of drafting an upper floor plan is to make sure that columns and column grid align precisely with the lower floor plan and especially with the ground floor plan, because the ground floor is basically the one that will give grounding to all of the building, right? So that will connect the whole building to the ground level, right? So ground floor plan is to be doubly checked always when we are doing upper floor plans, right? So first floor plan onwards, everything is to go and connect, everything has to go and connect, which is of structural relevant, has to go and connect the ground floor plan, okay? So if there are any other columns that are added or being removed on the upper floor, they need to be mentioned and added to the column grid, right. So, that is something very important. For example, we will discuss this in subsequent slides, but for example, if there is one column which is there on the ground floor and that goes to the topmost floor, that can be shown in completely, but somehow on a upper floor level plan, if a particular column is not going to be continued any further and it stops at this particular floor, then it is to be represented with a dotted line, right. All of these things we will discuss in the subsequent slides, right, of this module, right. Then furthermore, the grid more or less remains the same throughout all floor plans, right. So, we do not change the nomenclature of the grid. So, if we are saying 1, 2, 3 and A, B, C on this side, 1, 2, 3 on this side and A, B, C on this side, it will still remain the same throughout the drawings, throughout all the floor plans, right. So, we are not changing anything with the center line, the grid is going to remain the same, right. If a particular column terminates, as I mentioned earlier in this particular example, if a particular column terminates at a lower floor, that particular grid line is still to be shown for reference till the very end, right. So, this line, say for example, if a particular set of columns, if this whole set of columns which will be located here, say column 1, column 2, column 3, column 4, column 5. So, all of these 5 columns, they stop at this particular level, right, but the center line cannot be removed for the upper floor columns, right. We will discuss this with example in the subsequent slides, right. Moving forward, the next important structural element and next important vertical movement element for vertical circulation is the staircase. So, the staircase needs to be perfectly aligned with the lower floor plan, that is a thumb rule. If the staircase of the lower floor plan has moved on an upper floor plan, that is something odd, that is something which is not to be done, that is something which rarely happens. Only if there are very high order design liberties being taken, in that case and only in that case you will see a staircase shifting a little bit on the upper floor plans. But rarely you will see that when a building is quite vertical, it is not spread out something like a mall or something like that. If it is not spread out and it is a vertical residential or commercial tower, then in that case the staircase will always remain on top of each other, right. Each block of the staircase will remain on top of each other. Now, let us talk about the representation. In all of the drawings, all the staircase should have the number of steps, but along with that there can be a stairwell which may vary. So, the stairwell which is here, that may vary, all of this may also vary a little bit, right. But the stair landing, the rider height which is this, this should be riser height, right, this should be riser height should be always constant. Okay. So, these heights and these differences should remain always the same, right, and also the tread width also needs to remain the same throughout the staircase. Next, each step needs to be numbered. As you see in this example, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. On 9 you have a mid landing which is here, and then 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 is where you start with a new floor, right. So, you have 18 steps to come up to the new floor, right. So, each step is to be numbered and the final number is where your new floor starts, right, that is where the new floor starts, alright. So, depending upon this floor, depending upon the floor, there are 3 ways, okay, there are 3 ways to do different types of staircase in and the way in which you can draft the staircase in this particular project or any project where you are doing a building, right. So, the first way to do this is where you start the staircase where the floor starts, right. So, that is the whole idea. Next is where you have an intermediary floor, meaning that your floor starts at mid landing level. You have some amount of staircase steps at the beginning, then you come at a mid landing level and that is where your first floor comes in. Then you reach the next level, that is where your next floor comes in, right. So, there is intermediary floor also possible, right, or intermediate floor also possible. Next is the staircase where the floor where staircase ends. So, at a particular floor probably there is a staircase where it is ending, but you will be going to a basement. So that is where the staircase might also start, and that is where it is to be drafted. Okay, so these are some of the important things. More or less it's kind of a common sense, but then also there are several mistakes often that happen, particularly in case of annotations. How are those? We will look into this, right? So when we are doing all different three types of staircase individually, these are being shown as examples here. So if you see the first one, the floor where stair start. So we have a floor from where the staircase is going to go upwards, right? This way. So in the representation, how it is to be shown, till the point where the staircase will be cutting at the plan level, that is to be shown as a complete line, complete continuous line. As you see in the 3 steps, the 3 steps are completely drawn, right? And then the 4th step is also partly visible. Beyond that, all of this area you see is done in dashed line, right? This is discontinuous line. You have dashed a representation of that particular level. So meaning that this particular part of the staircase is going on the upper floor. So you will be going upwards from here, right? That's what the arrow also shows, right? Here you have an arrow, right? So that's where you go when the staircase starts at the floor where you are drafting your floor plan. Next, you are doing this on an intermediary floor, right? Meaning you will have a level between which there are 2 other floors on top and down, right? So you are representing both the cases, right? So in that case, you will show a complete staircase, but also you will have a cutout line, right? So you are doing a plane cut, which is meaning the you do a plan level cut line, right, which is this, and along with the cut line, the steps in the lower floor are also seen, which is this. All right. So there are staircases on the lower floor, that those will also be visible, right? But try to remember this particular situation wherein you have to observe the numbers. Here you have descending order of numbers, right? Here you have descending order of numbers, but there will be a staircase right on top of this from where the next flight starts, right? So the next flight would start at the mezzanine level where you come and land here, right? You come and land on 18, but this is the floor level which you will be using. So you will use 19, 20, 21, 22, 23, so on and so forth on the upper floors, right? So that's the thing that you need to keep in mind when you are doing intermediary floors, right? So this is one way where the reader or where the person who is going to refer your drawings is going to understand that yes, this particular floor is an intermediary floor by looking at the numbering and the way the staircase is represented. Moving forward, we are looking at a floor where the staircase ends, right? All right. So here what do we see? We see that okay, at this particular step the lower floor levels will be seen, right? All the steps in lower floors will be seen. How is it so? If you are going from this particular level, right, if we say that this is the ground floor level, but from the ground floor there is another flight which will go to the basement. So this is what we will see, right? So complete staircase will be drawn only when the staircase is going down further than the floor plan which has been drawn. Okay, so that is where we have to be very careful. So these are the 3 different ways in which the representation is done. All right, so something to be remembered, quite important. All right, moving forward. So when we have floors on top of which there are some kind of projections, right? Projections such as balcony, elevational projection, the projections of chhajjas and overhangs which are on top of windows, elevational elements such as boxing on top of windows or outside windows which frame the windows on all sides. So all of these different kinds of projections which we have, they are to be represented in the drawing as well, to keep a check and idea of how much amount of projection is going to happen, so that we can do structural estimate of whether that much amount of projection is possible or not, right? So in case of cantilevered portions, and projected slabs, right? So 2 important points: cantilevered portions which will be hanging portions which will be projected out and hanging, and some slabs which will be continuing outwards, right. The outlines of these portions should be marked in subsequent lower floors. That is very important. So, for example, this is where we see a balcony, but on the lower floor there will be a dotted line like this, right. So, there will be a dotted line like this which will represent the marking of this particular balcony on the lower floor, right. So, moving forward, the projection portion, right, the portion which is projected, dimensions and the level difference should also be mentioned, right. That is something very important. So, for projections as well, you need to mention the level difference which is there. So, here is where we see the level, and here is where we see the dimensions, right. This is to be done on the upper floor level itself. When you go from the lower floor level plan to the upper floor level plan, on the upper floor level plan, all the projections which had been drawn. So, all of the dotted lines which were there on the lower floor will become solid lines, continuous lines, and you will mention the height at which this particular projection is located and its dimensions as well, right. So, this dimension, this size would directly match with the dotted line area which is mentioned in the lower floor. Okay. So, very important. The next level, the next point is in case of sunken slab, even sunken depth can be mentioned. For example, in case of a slab wherein you will have a sunk, you will have a step down, right. So, that is also to be represented with a dotted line, right. And often when we have level differences, particularly here, this is a sign for tile drop, right. So, this is how we represent tile drop, something like this. Okay. So, in a general drawing, you represent the tile drop like this. So, what does this represent? There is a step down, and sometimes you can also mention a tile drop something like this with a level difference minus 15 mm, right. So, if you are mentioning that minus 15 mm, that means this level is higher than 15 mm than this particular level, alright. So, this level is a lower level, right. And that is usually that we see when we are moving from a room area to a balcony which is exposed on the other side, and this is particularly done to keep water in check, right. So, whatever rainwater is collected in the balcony, whatever dust that is collected in the balcony can be easily removed and taken care of. So, for that we have a tile drop, but when we have a tile drop, when we want to propose a tile drop, these are some of the signs which are to be mentioned here, right. So, even in level differences between balconies and rooms, we need to indicate near the door the appropriate symbol, which is this, correct. So, this is something to be remembered. Moving forward, right, when we have a double heighted ceiling, even in the previous module we did talk about this a little bit, but in detail what is to be done when we look at the ground floor level plan and the first floor level plan, what happens, right. So, in the ground floor level plan, if you see, there is a line here, right. So, there is a line here. In the upper floor level plan, we do have a line, but we do see the seating which is there below, right, and it is written seating below, right. Here it is written seating below, right, which basically means that you will be seeing something that is on the lower floor level, alright. So, something that you will see on the lower floor level, right. So, these are some of the interesting things which are to be taken care of when you are doing a double heighted ceiling. So, what are the important things here? For a double heighted ceiling, the area in the ground floor and the upper floor are usually mentioned along with the mention of a double height. Floor details and the ground floor details are usually mentioned along with the mention of double height. What is the way to represent a double height? You write it in text that this is a double heighted seating space, and along with that you mark it with two dotted lines similar to the representation of a duct, right. So, you mark it with two dotted lines, say this is your space. So, you will be marking it like this, similar to what has been done here, right. Then moving forward, on the first floor level, the lower portion will also be shown, but in lighter line weights, right. So, the line weight should be lower compared to the upper floor plan, other details of the upper floor plan, the lighter level of the detailing which is to be represented there. Along with that, there is also a requirement to show where the floor stops. So, if you see here, there is a faint line, probably there will also be a railing here, where there is a faint line wherein the floor will stop. This is the faint line which is there, right. So, this is where the upper floor level starts. So, to understand that some level is at the lower level and some of the objects which are shown, some of the furniture that is shown, that is on the upper floor level plan. So, that is to be clearly mentioned, right. The walls near the double heighted area should be represented as per the floor level, meaning that here you see that the walls are continuing, but on the ground floor level there is a folding door there, right. So, there is a door from which people can enter and exit from this particular place of the sitting area, right, or maybe it is a window which is going to a very quite a bit of a depth, and that becomes a double paned door as well, wherein you can move out and come back in, right. But that luxury is not available on the upper floor, right. There is a wall there. So, we cannot move out of the cutout and then pass to the wall, right. So, a wall is a solid entity, right. So, we represent it according to the floor level, right. Here the additional elements like doors and windows of the lower floors are not mentioned, just the furniture, whatever will be seen from the plan level, that is to be mentioned at the from the lower level or the lower ground level. Okay. So, that is something very important, right. 3 items, 3 topics. Okay. Next, so I did talk about floating columns or columns which will terminate at a certain level. So, we will be looking at what is to be done with the floating columns particularly, right. So, what are floating columns per se, right. So, imagine that you have a building and you are asked, this is the ground level, and you are asked to create a projection on the upper level, right. So, you have a column which is like this and you are asked to do a projection on the upper level. So, this is your beam on the top floor, but then your client also wants you to do a upper floor which has a completely covered area, right. So, then you will require a column at the end, right, but this column will not be supported at the lower level, correct. So, what do? You have a deeper beam here and you create a column on top of this, right. This section when represented in a plan would look something like this, right. So, here at the ground floor level you have the room 1, this is probably room 1, right, and then you are looking at this side. Okay. So, in that particular case what will you have? You will have this floating column represented in this particular way, wherein this beam is represented in this particular fashion, and the column which is there, the solid column which is there in room 1 will be represented in this particular manner, right. So, that is very, very important, right, and I think I mistakenly drew it this way, but it should be this way, I imagine, right, the section should be this way. So, you will be cutting this along this line and looking in this direction, right. So, when you do that you will get a section something like this, right. So, this is where you have your floating column, all right. So, in a plan when you are doing a floating column you have to represent the length of the projection, the width of the projection as well, right, and the center to center distance between 2 columns will also be there when you have the center line, that is not being mentioned here, but on the ground floor level you will also have the center line. This is just a representation of what exactly will happen, right. So, on the upper floor levels the columns are shown as regular columns, right, but on the lower floor level you will have to mention it in a with a better clarity, right. So, that is the complete idea of representing a floating column. It is very important, particularly because this particular space will be cantilevered space, right. It will be cantilevered on top of it, top of the on the upper level floor, right, on top of this particular ground floor. So, it is very important that that is represented correctly on the ground floor level as well, right. Moving forward, right. So, what happens when columns get terminated? right? Columns don't continue on top floor, right? Say for example, in this particular case itself, this column does not continue as we have mentioned it here, right? This column does not continue up. So what happens? Then that particular column will be represented in dotted lines like this, right, on the ground floor level slab. Ground floor roof slab, sorry, ground floor roof slab. When you go on top of the first floor and you see the plan, this is the way it is to be drafted out. Say for example, there is another column which reduces in size, right, because there is no load on top of that first floor or very less load on top of that first floor. So you are going to reduce the amount of concrete to be used in a column, and you will make a smaller column compared to the column on the ground floor, right. So even in that case, the lower levels lower level column or lower level ground floor level column should be shown in complete dimension in here in dotted lines, right, or in dashed lines. That is very important. So two things which are very, very important: the way of representing of columns which are terminating and the way of representing columns which are reduced, right. So two ways which are very important, right. So often this note is also mentioned when these kind of changes are happening, because sometimes there are printing errors, right, which may get overlooked. So it is always better to have a double safety check by mentioning this note. Sometimes there are also representations on the side with a notation that CC, right, to double check. So for example, this is being marked with the notes side of your column of your drawing template, and in CC under the notes section it will be written column change, right, and under the column change you will be writing whether it is terminated, whether whatever has happened. So you will mark this CC1, whether mark this CC2, something like that, right. Sometimes there are clouds also, right, so you put a cloud around this, right. So it is also called as a revision cloud, right. So these are several different ways of representing changes that are happening in the drawing or revisions that will be happening in the drawing, right. So these are some important things to be kept in mind, various different ways of annotating the changes, right. Then on the upper floor levels there may also be water tanks or water storages, right. Sometimes these tanks are movable, sometimes these tanks are solid, so they are made in RCC, right. So in either of the cases a water tank is to be represented very in a correct manner, right. So in the plan way, the way you represent the tank is somewhat like this, right. So what all do you present? The columns which are floating from the first floor level, right. So meaning that if this is on the top floor and the building is up till the first floor, you will represent these 4 columns which will take care of the water tank, right. The roof slab will support this particular area, and there needs to be a platform as well, right. So you will draw all of this on the plan level as well as in section. So water tank sheet is also separately shown along with the complete dossier of the working drawings, right. So what all do you have in there, right. So water tanks are positioned in the terrace floor and they are represented in 2 ways, right, 2 ways depending on the type of the tank. So a plastic tank, if you have a plastic tank, something like if you name a brand, Syntex tanks, right. So if we are having that blue or black tank on top of our building and we are going to fill it with water, that is a movable tank, right. So all that you need for that particular tank is just a podium, a platform to place it flat on a flat ground, right. It shouldn't buckle. If it buckles, it will create damage. So you need to have a flat surface to put the tank on top of it. The other one is represented here, which is RCC tank, right. In case of a plastic tank, the slab with which on top of which it will be placed, there should ideally be a side wall and the column support for the slab. So in some cases the tanks are directly placed on the terrace level itself. In some other cases tanks are also elevated. So in this case, if it is elevated, a column support should also be represented, right, to the slab. and design needs to be shown in the plan. So whenever you are doing that plan of the terrace, you also need to show those 3, 4, 5 columns or 6 columns on top of which you will place the water tank. So that is very important. Next, when you are doing a RCC tank, the RCC wall for the tank should be structurally designed for the building capacity. The capacity calculation is very important, because RCC is cast in situ, and changing the RCC tank or modifying the RCC tank is a lot of would probably happen with a lot of difficulty, right? So breaking down a tank into half and then extending it creates a lot of problems in future, right? So water leakages and issues. So instead of that, a tank would probably be completely broken down and then made anew, but that also is very expensive. So in that case, a very well organized calculation with a safety factor is expected when you are doing the complete drawing, and only then when you are doing the project with the projection of how many households will be living in that particular building. So based on that, the consumption is calculated, and with that consumption calculation you will be doing the volumetric calculation of that complete RCC tank. So all of that is a prerequisite before you even do the drawing of that water tank, right? Moving forward, when we have mezzanine floors, right? So mezzanine basically are intermediate floors, right, which are sometimes partly open, and they are also, they have some kind of access to the lower floor, right? Or sometimes they don't have access, they are just elevated on top of this, right? So it's basically creates a double height in the ceiling room, right? And it's particularly done to bring in more light, more air, and more ventilation basically, right? This kind of a level or this kind of a floor, mezzanine floor, is used in both commercial buildings, residential buildings. In case of commercial buildings, often mezzanine floors are used to make lofts, larger deep lofts. Sometimes restaurants, to add additional seating capacity, they make mezzanine floors so that people can go and stay on top of that particular level, like use that particular floor. Like for example, in this particular example, if you see, this is the ground floor level plan, and on the mezzanine level you have 2 cutouts, right? So you have one cutout here, one cutout here, one cutout here, and you have a lot of quite a big area wherein we can have extended seating. This is just an example of the coffee shop, right? So as I was giving you an example of a restaurant, so in the same way you have a lobby here, people can go up, and this will be a reduced height area wherein people can go and use this particular office space or conference space or extended seating area for larger groups to enjoy this particular space. And on the other side you will have an overlooking space which will be double heighted on top of this particular sitting area, right? Also this particular garden area will be open to sky. So these are some of the interesting things which are there. Usually the mezzanine floor does not extend, mezzanine floor does not extend beyond 1/3 of the floor space which is below, right? So it is not considered as a separate floor. If it extends, right, if it extends beyond that, it will be considered as a separate floor. That's why it is not considered as a upper floor, or not considered as a complete upper floor. It's a floor which is intermediate, it's in the middle, it's in the intermediate, right? So that's the whole idea. Okay, moving forward. So what are the other ways in which you see a mezzanine floor, right? So in here, when you see that this is a very compact kind of a house, you have a kitchen below and you have a double heighted dining area below, right? Kitchen and double heighted dining area below with a family room. I think this should be family room, not this should be family room, right? So on the ground floor people can come in, right, or you can use these windows, and once you go up, you are around the dining area. Once you go up, you are coming up to this particular family room area, right, which can probably, the sofa will fold out to create a bed or something like that, right? So it's a compact dwelling, right? But these kind of issues can be solved, can solve area related problems, meaning some places like some countries like Japan have a space challenge. So there the minimalistic housing is much more required, right? Cities like Delhi, cities like Bombay, Bangalore in India as well are having these kind of issues. So if you are able to make compact dwellings for people to occupy the space, we are able to make compact studio dwellings as well, wherein you just require the dining area, the kitchen area and one area to sleep. The dining area can be doubly used as living space as well. So in that case, instead of a complete first floor plan, you can do with a half, right, or a 1/3 dimension of the lower floor plan, wherein you can introduce a semi first floor or a mezzanine floor to do to occupy people in a very less amount of space, right. So that's all possible. Next we move on to the roof plan, right. So moving from all the habitable spaces to all the to the space wherein we have a complete covering, a complete shelter on top of this, right. So roof is the uppermost part of the building, which is quite a common sense, but moving forward with that, a roof plan essentially is just a upper level looking down view of the building roof, right. So we are going to go on top of the roof and then see on the bottom right from the top of the roof, and then we will try to draw that particular plan, how it will look, how it should look ideally from the top, right. So roof plans are basically used to understand what is the shape of the building, right, what is the shape of that particular roof on the top floor, right, on the topmost floor on the roof, how is it shaped, whether it is sloping roof, whether it is flat roof, whether it is partly sloping, whether it is doubly sloping like a gable roof. So the additional idea of how a building would particularly end on top, right, would converge on top, that is something we understand, right. In a terrace floor plan, if it is a flat roof, it often cuts out a staircase, right. So you would also have a staircase headroom, wherein you come out of the staircase and you can access that particular terrace area. So all of these things are to be mentioned in the drawing. So we will discuss how it is represented when we go forward with this particular part of the module, right. So regarding the roof or the terrace plan, all of these informations are important to be shown. First is the drainage plan of the roof. How are we going to drain the whole roof? That is to be represented. Next, the dimensions of the roofs and the details of the roof. If it is a sloping roof, all the details are to be mentioned. If it is a flat roof, how will be the corners of the roof treated? That is to be mentioned. If the direction, if there is a slope which is being given, what is the direction of the slope of the sloping roof? That is to be mentioned. The location of the rainwater pipes is to be mentioned. The details of the rainwater pipe is to be mentioned. Then along with that, you also need to mention the column details, whether the columns are terminating there or a building which has plans to expand in future, plans to increase the number of floors in future, often leave some of the columns as runner columns on top. So these columns can be, the concrete in them can be broken down, and then you can splice the upper rebar and then you connect the upper floor, then you develop and construct the upper floor to connect the lower building, existing building, with a new extension on top, right. So that representation also needs to be done, whether on the terrace floor all the columns terminate or they are going to remain there, right. So in that case you have to do a different kinds of encasement for them, right. So that all of these things are to be mentioned. Now this is an interesting representation of how a roof plan is very important. So just by observing, do we have any difference if we represent the roof plan, even if the roof is flat roof or it is slightly sloping? Probably not, right. It just requires is represented as a rectangle within a rectangle, right. So a rectangle, this rectangle is the outline of all the floor, all the wall that is there on the lower floor, and we have the roof on top, right. But in this case you have a sloping roof, but the same is being shown as a representation of the sloping roof, right. But what changes the whole idea is when you introduce an arrow, right. So the moment you introduce an arrow, this shows that yes, this roof is sloping in this direction. Right. This point is higher compared to this point. This point is higher compared to this point. So, this point is at a higher level than the point towards which the arrow is pointed. Right. So, this is how we show the or represent the roof. Right. And then it is represented this way. So, that also means that there will be a gutter on this side, right, which will collect the water and probably take it down on the lower ground level to store or to drain off. Right. So, even slightly sloped roofs are quite common. A roof usually is not completely flat, it will have some amount of rolling slope to drain out the water. Right. That is very, very important, so that it does not collect and become a storage point of water. It should take down the water, because if a lot of water gets collected in the roof, it might create hazard and the roof might also cave in, because water is really heavy in large quantities. Water is really heavy, so we need to be very careful when we are doing the roof plan. Right. Moving forward, when we have two-way sloping roofs, which is a gable roof where it slopes like this as well as like the other way. Right. So, in that case you will have two-way sloping roof, right, this, right, and then you have a hip roof as well. So, in hip roof all four sides are sloping. So, you have slopes on all four sides, right. So, in that particular case you will represent it somewhat like this. Right. You will have arrows, sometimes arrows are not shown either. So, you may have arrows and you can also show or represent it with the degree in which it is sloping, right. So, in locations where there is a lot of rain or locations where there is some amount of snowfall, which is quite common, you see both of these type of roofs. Both these type of roofs are quite common in those areas, right. Places where it rains more or less not that much, right. So, that case you will have one-way sloping roof, right, where rain is not that common, and in several of the dry areas you will see roofs which are predominantly flat, right, with a very minor amount of rolling slope on top of it, right, so that you can drain off water. So, this is how you represent a completely pitched roof plan, a plan wherein you have complete pitches, whole roof is pitched, right. So, this would be a composite of the hip roof, right, because it is sloping on all sides. It is sloping here, it is sloping here, here as well, right, on both these sides as well, right. So, you will have a ridge line, which is this, which is the top of the roof, and you will have the valley line, right, wherein the two slopes meet, right. So, the place where the two slopes meet ideally become the place from where you take the water down, right. Water will also drain out from here, but you will have to make a gutter on all sides, right, which is very important. Okay. So, this is something which comes in part of representation, right. When we go to the structural consultant, this whole thing might get converted into this. This is just a part drawing of one of the gable roofs, which hip roof which we may have. So, you have four ways in which this roof steeps down, but to do this you will require three different types of trusses, one truss, two truss and truss number 3, right, three different types of trusses to do this, because the span keeps on changing from this point to this point to this point, and it is supported at 1, 2, 3, 4 locations, right, and it extends further to create a eave, right. So, to have those eaves and to have that gutter at the end of it, you require a sloping, you require to have this kind of a representation. Again, in a detailed floor level plan like this, you need to have the column center lines represented, you need to have the complete dimensioning, you need to represent the distance from where the column center line, from where the eave is located from the column center line. How much is the distance between the end of the roof and the column center line, that is also to be represented on both sides, right. Then column center to center location is to be mentioned, which is also sometimes referred to as column center to center, but in other case if you are doing a roof plan and it is a wooden roof or a steel roof, then your members center to center is also to be represented, also to be mentioned, because sometimes the trusses are off centered like this one, or sometimes the trusses are in the middle of the column. So in that case the column center line and the truss center line becomes the same, right, but in this case the truss is off centered, right. So here we have both the trusses, truss number 3, both the trusses along the center line, right, but here we do not have the truss 1 on the center line, neither is the truss 3 on the center line, right. So the center line of the trusses will be a bit different, and that is why we need to represent the distance between them as well, right. So that becomes our detailed roof plan, right. Moving forward, when we look at a terrace floor plan, terrace especially when we look at terrace, most of the terraces we say will always be flat, because we are going to walk around that area, and it is essentially a floor plan which is connected to some or the other kind of living area or some or the other kind of activity area, right. So terrace is a place wherein you can go walk out and get the feeling of the sun or sunlight or the wind which is there around that area, right. You feel the exterior environment, right. So that is how terrace is useful, but usually what we have is in the terrace we have to show the other rooms as well. For example, in this particular residential case, you may see that there is a terrace which is this, and it is common terrace which can be accessed from this particular place. These two doors are there to access this particular area, but you have two flats, right, two apartments in that particular floor as well, okay. So both the things are to be mentioned. If there is just a staircase, you have a bungalow and there is a terrace, so there will be a staircase coming up, there will be a water tank which will be located there. So both things are to be reasonably highlighted, right. So the details which are to be represented in case of a terrace floor plan, let us check that, right. So the directions and level differences for the slope of the water drainage, right, to identify how the water is draining, that is very, very important. So here you may see that you have slope lines, right. So you will have slope lines which will represent also the location of the rainwater pipe, right. Along with the rainwater pipe, you also need to mention, so here in very light words it is mentioned that you have 0.10 meter of rainwater diameter rainwater pipe, RWP, right. So you have a 0.10 meter, meaning 100 diameter rainwater pipe, which will take down all the rainwater which is here, but all of these are located in 4 different locations, right, meaning that water which will drain out from this particular location, probably there is also a rainwater pipe here and another rainwater pipe here. So all of the water which will be collected here will be drained out here, all of the water will be connected here will be drained out here, this level of water will be drained out here, right. So you will have 3-way sloping, 1, 2 and 3, right. So this is the whole ideal situation in which you drain off all the water from the top from the terrace surface level, right. So the last thing is the mention of the columns, right, and the remaining height which is left. So for example, if you have a column which is jetting out, right, in this case it probably looks like the column goes on continuing, but if it is getting if it is completing at the level of the boundary wall of the terrace, it is to be represented as a stub column, right. So it is just a runner column which will be providing some support to the later extension of the building, right. So that is to be mentioned on the side of the remaining column, right. But these details you rarely get to see in drawings, because in most cases terraces are flat and we do not do adaptive reuse of buildings much that often. So we do not leave the runner column coming on top, right. That is a rare thing to see in case of working drawings often, right. So this is how a terrace floor plan will look, right. So you have rainwater pipe detail, as we discussed earlier. There will be there is a 0.10 meter rainwater pipe, right. So, that is located here, and the direction of the slope is also mentioned, right. So, it is very important. So, if you observe, you have two rainwater drainage points, right, rainwater drainage point. So, if we divide the whole terrace into two parts, right, and imagine that there would probably also be another rainwater drain here and here, and another rainwater drain somewhere around here, here and here, right, to have pipes which will take down water from here and here, here and here, right, 4 places water will go down, right. So, what will happen is that you will always have the slope which will point towards this direction, right, and this area as well you will have slope which will point towards this direction, right. So, this is how the distribution of water would happen with a very low level ridge, line, and then you create simple slopes, rolling slopes, so that water rolls out with its own weight and gravity, right. So, that is how you drain out a terrace. Okay, very important, and to be considered for all the different drawings and all the different structures that you do of a terrace plan, right. Then furthermore, so in case of a truss roof, that imagine you have a truss, as we were discussing earlier, imagine you have a truss on top of this and you need to show the truss roof detail, right. So, in a case of that, what do? We have the column center lines, and you also have the truss center line. So, here you see the center line of the column is 10 feet by 10 feet, but the distance between two trusses, right, it is 9.9. So, each of the truss is about 2 inches thick, right. So, 1 inch gone here, 1 inch gone on the other side, right. So, each of the truss is about 2 inch thick. So, this is what is very important, right. So, which is to be represented in a very clear way, right. So, if we look at purlins, the purlins are to be shown in dashed lines. So, here you see all the purlins are visible in dashed lines, right. You also see the top ridge, right, that is also represented, and the overhangs of the trusses, which are here, here and here and here on all 4 sides, right. These are also to be mentioned when you are doing a sloping roof. It is very important. So, at that particular location you can propose, as you see in this, there is a double dashed line, right. At this particular location you can have a gutter to collect all the water that will drain out from this particular roof plan, right. So, that is very important. Often when you have a sloping roof on top of a terrace plan, it is not expected that you will collect all the water in the terrace and then try to drain off the terrace, but it is always advised that you have a separate gutter for the sloping roof, sloping covered area as well, right, which is very important. So, in this kind of a development, if you enhance this particular as a roof plan, your part of it will be terrace, your part of it, the other part of it will be in case of in represented as a sloping roof, right. And here if you observe, there is a gutter. Here if you observe in dotted lines, you see the columns which are protruding out, right, and the outline of the wall which it covers, meaning that this much of the part is a overhang, right. This is overhanging and projecting out something of this sort, right. So, this is what you see as an overhang. Okay. So, this is what is very important, right. So, that is how it is represented. Also, if you see here, these are the places where the columns terminate and they merge, right. So, the column merges with the boundary wall, right, with the terrace floor, right, boundary wall on top, also called as a parapet, right, also called as a parapet wall. So, where the parapet wall terminates, that is where the column also terminates. So, it is merging the level with it, right. So, if you have sloping roofs on top, so what are the other ways of doing sloping roof? So, you have terracotta roofs, you also have some imitation terracotta roofs now available, wherein you can get the look and feel of a terracotta roof, but you will have this material will be available in UPVC or some other fiber, right. There are several other materials available, but it requires a deeper market survey to actually identify how many types of material are available. So, that is available to have the look and feel of Bangalore tile kind of layout on the roofing. Then you have corrugated metal roofs, right. So, corrugated metal sheets, you will see earlier there were asbestos sheets which had this kind of a profile, right, but now they have been discontinued, you do not get that anymore, right. But you definitely get metal corrugated sheets which are relatively cheaper, or some of the most cheapest material available for doing a pakka house, right, with a sloping roof on top of it, right. Along with that, in rural areas you will see that there is thatch roof being used, or even in resort kind of structures you will see that in some places you have a composite of metal roof in the bottom, metal roof on the inside of this, and on top of that you layer it with thatch roof. So, you have good amount of water protection from the rains, and you also have very good way of draining out the water that falls on top of it. Also, it is a very good insulator. So, in places where there is some kind of heat flash which will be coming, heat wave which is a common thing that happens, if you have a thatch roof on top, it will contain a lot of it will cool down a lot of temperature within the room, right. It will keep the temperature within the room cooler, that is very important. Along with that, you have wooden shingle roof as well, right. So, you can also do pieces of wood. Sometimes these are also done in pieces of slate, right. So, slate is a stone, so that comes as wafer, right. So, it is layered, it is sedimented stone, it is layered. So, you can use slate shingles, right. So, these shingles, if they are cut in pieces, so they are put together, they are tucked together, and they are hammered with one layer, with the lower layer is laid down first, then you put down the upper layer. So and so forth, you keep on doing that, you keep on nailing them on purlins and setting sheets on top of that. So, you put the wooden roof in that particular fashion, right. So, these are quite common in areas where there is a lot of snowfall. So, these roofs are quite stable in such kind of locations, right. So, these are some of the 4 most commonly used roofing materials in all of India. All right. So, that was about the module today, and moving on to the next module, we will be coming back to you. Thank you very much.